I've been there. We've all been there. In my 13 years at Vertex, I've learned that the most expensive technical debt isn't the code you write badly, it's the infrastructure decisions you avoid making until you're forced to make them during an outage. Today, I want to share a framework that's helped us stay ahead of our scaling needs without over-engineering ourselves into complexity. It's called the Goldilocks principle of infrastructure design. Now, the Goldilocks principle is simple. Your infrastructure should not be too rigid, too flexible, but just right for your current stage plus next stage of growth. Let me illustrate with a story. 3 years ago, we had a client who was processing about 10,000 transactions per day, and they had three choices. The first choice we called the Papa Bear because it's too rigid. They could build for exactly 10,000 transactions. It's cheap, simple, but it breaks the moment they succeed. The second option we called the Mama Bear option because it's too flexible. They could build microservices architecture with auto-scaling, circuit breakers, and multi-region deployment from day one, massively over-engineered for their current needs. And the third option we call the Baby Bear option because it's just right. You build for 30,000 transactions with a clear upgrade path to 100,000. Room to grow, but not drowning in complexity. Now they chose the Baby Bear option, and 6 months later, they hit 25,000 transactions per day. Instead of emergency architecture overhaul, we spent 2 weeks implementing the next phase we had already planned. And that's the difference between reactive firefighting and proactive scaling. The key insight is this: design for your current scale times 3, plan for times 6, and build escape patches for times 12. It's called the 3-6-12 rule. Now, how do you actually implement this? First, let me be clear. Even with good planning, you need to recognize when your current approach isn't working. There are specific warning signs that tell you when your infrastructure is approaching its limits, and I'll talk more about those in our discussion. Now, there are 4 foundation elements that must be right from the beginning. First, data architecture that doesn't lie to you. Your database is your foundation. Get this wrong and no amount of application scaling will save you. Now, the principle here is to design your data models for reads, not just writes. I've seen teams all the time who optimize for fast inserts but never think about queries until they're doing table scans on millions of records. Now, we always implement proper indexing, consider read replicas from day one, and design APIs that don't create N+1 query problems, because it's easier to add read replicas when you need it than to redesign your entire query structure during a performance crisis. Next, monitoring as infrastructure, not an afterthought. Here's something that might seem obvious to others, but bears repeating. If you can't measure it, you can't scale it. Our rule is no code goes to production without 3 things. Application performance metrics, like response times and error rates. Business metrics, like transactions processed and user actions. And infrastructure metrics, like CPU, memory, database connections. We treat monitoring code with the same rigor as feature code. When something breaks at 2 a.m., you want data, not guesswork. Now third, you want a caching strategy that grows with you. Caching is the difference between a system that scales gracefully and one that falls over. But most teams implement caching reactively when pages are already slow. Implement caching at 3 levels from day one. Browser caching for static assets, application caching for expensive computations, and database query cachings for repeated lookups. Start simple with in-memory caching, But architecture cache calls, so you can swap in Redis or Elastic Cache when you need distributed caching. The interface stays the same, but the implementation can evolve. Now finally, design your API for future you. Your APIs are your contracts with the future. Design them thinking about the developer who will maintain the system in 2 years. And that developer might be you, but you'll have forgotten everything about why you made these decisions. And make common things easy and complex things possible. Design your APIs with versioning from day one. Implement proper pagination even when you have only 100 records, and use consistent error handling patterns. These decisions are nearly impossible to change later without breaking client applications. But here's the critical balance. You want flexibility, but not so much flexibility that your system becomes unmaintainable. There are specific practices that help you avoid building systems so flexible they become impossible to maintain, and I'll share those techniques in our discussion. Now, even with these principles, teams still make predictable mistakes. Let me share 3 most expensive ones I see. And these represent the most common places where teams overcomplicate their infrastructure prematurely. The first mistake is the Netflix fallacy. Just because Netflix uses microservices doesn't mean you should. Netflix has 15,000 engineers, you probably don't. Teams break apart a working monolith into 12 microservices before they understand their domain boundaries. Now, instead of one system to debug, they have 12 systems and a distributed systems problem. Start with a well-structured monolith. Extract services only when you have clear ownership boundaries and operational maturity to run them independently. The second mistake I see is premature distribution. Multi-region deployment sounds impressive in architecture reviews, but it's operational nightmare fuel unless you actually need it. Unless you have users in multiple continents or strict compliance requirements, multi-region deployment quadruples your operational complexity for minimal benefit. Design for multi-region, but deploy single region until you actually have global traffic patterns. And the third mistake I typically see is the configuration explosion. Teams often think flexibility means making everything configurable. This leads to systems with 200 configuration parameters that no one understands. Don't make something configurable until you have 3 different use cases for it. 2 use cases or less often leads to premature abstraction. 3 gives you the actual pattern. For example, we had a client with a flexible notification system that had 47 configuration options. It took 3 days to onboard new team members just to understand the notification logic. We refactored it to have smart defaults with 5 configuration points. It was the same functionality, but 90% less complexity. Now, let me leave you with 3 things you can do this week. First, implement the 3-6-12 audit. Look at your current architecture and ask, can this handle 3 times our current load? Do we have a plan for 6 times? Do we have escape patches for 12 times? Secondly, add the missing monitoring. Pick one critical path through your application and instrument it end-to-end. Response time, error rate, and business impact metrics. And third, document your scaling assumptions. Write down what you think will break first when you grow. In 6 months, you'll either validate your assumptions or you'll learn something valuable about your system. The goal is to build the perfect architecture from day one, that isn't to build a perfect architecture from day one. The goal is to build an architecture that can evolve gracefully as you learn more about your actual scaling needs. Now remember, scale your architecture like you scale your team. Thoughtfully, with clear growth paths, and always with an eye towards maintainability. Thank you.